Hey guys, so today we are going to learn Norton's theorem. In Norton's theorem, you guys need to know three basic things. If you know these three things, then you will not have any issue to answer any questions which is coming from Norton's theorem. The three things are: one is theorem, which is given here, and the basic diagram, and its formula. These are the three things that you had to know. In this, you guys can see that any collection of batteries and resistance with two terminals is electrically equivalent to an ideal current source I in parallel with a single resistor R. So here uh, they are saying that we can replace the voltage. Two terminals, they mean by, a positive and a negative terminal. So there is a voltage in an entire circuit. We can replace that with a equivalent current, okay, and which should be parallel to a resistor. That is what they say. This is what the definition is all about, and this is the diagram. If you guys have seen Thevenin's theorem, it is almost similar to Thevenin's theorem. You guys can see that the equation is this. The diagram is this. IM, Rn is parallel to this, and RL is resistor, load resistor. And to find an ideal current, this is the formula that we had to apply. IM means current in, according to Norton's theorem, IM into Rn divided by RL plus RL. Let us find out what is IM, Rn, and RL. Okay, I have now this is the diagram, and I am going to show you guys one example diagram by which you will get an idea about it. This is the example diagram in it. In this, RL is nothing but the load resistor. This kind of, when they ask this kind of problem, they may ask they may ask some questions like find I, something like that. So what we had to do is like find I. So I is actually passing through this portion. Okay, this is the portion where I is passing through. So we don't know the value of I, and so the unknown current which is passing through this place, this portion. Okay, when it passes through this resistor, it will become RL. Okay, so if the unknown current is passing through this portion, then 3 ohm will be RL. Here, unknown current is passing through this portion, so 2 ohm is RL. Then RN is nothing but the overall, uh, we have to uh, get the overall value of other resistors. For example, like here you guys can see 3 ohm and 6 ohm are there, which are parallel. So that means Rn is nothing but uh, when two resistors are in parallel, you guys know the formula. That is this. Resistors are in parallel. R is equal to R1 into R2 divided by R1 plus R2. So this is the formula that we had to apply to find Rn. Okay. Like Thevenin's theorem, first what we need to do is like we had to draw this diagram like this, and the unknown current which is passing through this portion, we had to make that as a open circuit like this. So when we make it as an open circuit, you guys can see 3 ohm is there and 6 ohm is there, which are parallel. So 3 into 6 divided by 3 plus 6, that is 18 divided by 9. So that is 2 ohm is Rn here. You guys can see that Rn is equal to 2 ohm. 3 into 6 divided by 3 plus 6. 18 divided by 9 is equal to 2 ohm. And RL, as I have mentioned before, RL is the unknown current which is passing through some particular resistor. That is what RL is all about. So here it is 2 ohm. So RN is 2 ohm and RL is 2 ohm. Now what you need to do is like you had to find IN. IN is nothing but the voltage which is going through this. I mean, here you guys can see 21 voltages there, volt. This one, this I is actually passing through this way. The voltage is passing through this way, through this 3 ohm. And it is an open circuit. And there is no resistors over here. So, sorry, I mean, not, voltage is not passing through, current is actually passing through. Okay, so here what we need to do is like, as we know, I is equal to, I mean, V is equal to IR. So I is equal to V divided by R. Okay, that is a formula that we had to apply here. So when the current passing through this network, when it reaches here, it can go to this side and it can go to this side. But here one resistor is there. But here nothing is there. It is an open circuit. So always current tend to flow to this area. Okay, because it doesn't have any resistors, this area. So it goes to this side. So that means when current goes to this side, from this side, so we have one resistor and one voltage here. So by which we can find out IN, that is 21 divided by 3. Okay, that is this 21 divided by this resistor. And we are not doing anything with this 6 ohm here, because 6 ohm is over here, and when current reaches here in this junction, it will go to this area because it doesn't have any resistor. But here there is a resistor, so always current prefer to go to this area which doesn't have any resistance. So it will go to this side. So we had to consider 21 and 3 ohm. So that means 21 divided by 3 is IN. So IN is equal to 21 divided by 3. That is 7A. So the diagram, basic diagram will come like this. Instead of IN, 7A will be there. And instead of RN, 2 ohm will be there. And instead of RL, 2 ohm is there. Like this. So directly we can apply the formula to this equation. That is what I have done here. So we got IN, RN and RL. So I is equal to IN into RN divided by RL plus RN. So that is 7 into 2 divided by 2 plus 2. That is 14 divided by 4, which is equal to 3.5 A. So this is the answer. And I hope now you know what is the Norton's theorem and its definition and its equation. So now you know some basic idea about Norton's theorem. Okay, and if you guys have any more doubts, please ask me. You can just uh, write one comment if you have any doubt, or you can just directly message to my channel. I will reply if you have any doubts related to Norton's theorem. Okay, so these are the formulas that we had to know. This definition you don't need to by heart, but you had to memorize. You had to know what is what. And this diagram you had to memorize, and this formula you had to study. Okay, I is equal to IN into RN divided by RL plus RN. These are the most important things that you had to learn. And here I have explained one basic problem as well. This problem is more than enough to get a thorough idea about the Norton's theorem. So thank you for watching this video. Please subscribe my channel if you like this. So I will be uploading other related videos. I mean basic electricity related videos very soon. So subscribe my channel and be in touch.